Good morning, all. Am I audible to you?
So, yes,
Okay. So your exam is over now. Back to class again. Okay. Anyways, in last class, I just gave like little bit brief about B tree. We already started B tree. So I have already explained different properties of B tree and how B tree works. Okay, so today we will see how we can insert and delete items from a B tree. Let me share my screen first. Anyway, so B tree it is M-way search tree. So the properties or the way it follows is just a search tree, just that it is not binary. Binary means two children, but in case of B tree, there will be more than two children. Again, the main properties of B trees are like that. If it's a M-way tree, that means if it is a three-way tree, that means maximum children it can have is three. Then there will be different keys inside the node. That means inside the node there can be one, two, three, and all nodes. So if in a B tree there is a m children, then m minus 1 keys are possible. Okay. Again, it will just follow the binary search tree. That means all the elements to the right will be greater than the parent and all the nodes in the left will be smaller than its nodes. Okay. So I'll just directly go to an example. So insertion, okay, let me show the steps first. Application I already explained. So there are actually two versions of B tree. One is B tree, one is B plus tree. Both are almost same, just a bit different. So for insertion, we will just follow the same step. If it's empty, then insert the key and all. Okay, I just go to the example. It will be easier for you guys. Okay. So example, just think I am going to insert like 1 to 10 number. Just 1 to 10 number. Okay, it will be 1, 2, 3 and up to 10. Okay, so I'm also mentioning that the order should be 3. Okay, so the main task here is to create a B tree of order 3 and the values will be from 1 to 10. So if your m is equal to 3, how many keys will be there? It is m minus 1. Okay, m minus 1 means what? 3 minus 1 is 2. That means for every node, there can be 2 keys inside one node. Okay, so just first start with 1, it will go sequentially. And remember, when you create a B tree, it will be a bottom up approach. That means it will grow from downwards. Another property of B tree is what? Everything, all the leaves will be at same level. That means what? Normally in binary search tree, we just put everything from the root, right? First we take the root, then we just insert left and right sibling, then so on. That was your top-down approach. But in case of B tree, we will start from the leaf level because all the leaves have to be in same level. So first, suppose I want to insert one. So this is one node. I'm just creating one node. So inside the tree node, there can be two keys, right? So in this node, first I'll just insert one. Okay, the first element is one. Then our second element is two. Now, see, there is a space here, so I can directly put two here. Okay, so again, it's a binary search tree, and if the nodes are still empty, means if you have space in a node, then you will insert an item in sequential order. That means in ascending order. So two you just directly cannot put in front. You have to put it after two. It will just follow the BST rule. Okay. Next two done. Next we have three. Now what happens? I need to add three here. Suppose I added three here, but it's a overflow condition. Why? The maximum key in a node is two. But if I insert another item, that means it will be three. It's um, overflow condition. So in this situation, what we will do, we will just insert it. Just imagine I have just inserted this three. Then we will find the median value. Okay, we will find the median value. Then we will push that median value one level up to make it a parent. Okay, see even here it's written. If node is not full, we will simply insert the node in an increasing order. So after 1, I just added 2, right? Then again, if node is full, follow the following steps. Insert the elements in increasing order. Now there are elements greater than the limit, so split at the median. Okay. Then push the median key upward and make the left key as the left child and right key as the right child. So steps are already written here. So once I insert 3, so what is the median element for this? It's 2, right? So what I'll do, I'll just push these two up here. Okay, there will be a one node. Okay, maximum key can be uh, 2. So I'll just put 2 here. Okay, I'll just insert this 2 up there. I'll push up there. So after that, your 3 will be 2 will come here. Then left child, left key will be the left element 1, and the right one will be the right child. Okay, so 3 will come here. So this will be your left child of 2 and this will be your right child. Again, I just put just 2 to space. Why? Because in one node there can be 2 keys for an three-way key because your order is 3, right? So is this step clear? So the moment we will get the overflow condition, that means it exceeds the maximum limit of keys, then we will just find the median and push it up. Okay, then we will simply make the left element as the parent of the push up element, then right side of the element and the right children of the push up element. Okay, so after this, now, okay, hello, hey morning, hey class lesson. Class kora apa sih? Okay, so our next element is what? We have inserted 1, 2, 3. So next element will be 4. Now again see for this thing, 2 is the parent, 1 is less than 2. So it comes left of 2 and 3 is greater than 2. So I'll just put it in the right side. So it's again a BST rule. Okay. So now you see again, now we have 4. 4 is greater than 2, right? So I'll put it in the right side. So for this node, space is available. So I'll just insert 4 at this position. Okay. Our next element is 5. Okay. Again, 5 is greater than 2. So I'll come to this node. Now I'll put 5 here. But again, it's a overflow condition. Correct. So at this point, what I'll do? Again, the same process. I'll take the median. Suppose just imagine I have just inserted 5 here. So take the median and push it up there. Okay. Then make the left element as left of the push up element and right as right element. So what will be the answer here? After this, your key will become 2. So I'll push 4 up there. 4 will come here. Then this remains same. For A, there's nothing. 1. Now we have 3 and 5, right? So 3 will be the left of 4 and it is the right of 2 because 3 is greater than 2. Again for 5, I'll put 5 here. Okay. So 5 will come to right of 4. So again it's following the BST property for this key. 1 less than 2. So it's left side. 3 is greater than 2. It's in right side. Again for this key, 3 is uh, less than 4. It's in left side. It's greater than 5. It's in right side. Okay. So are you getting it? How we need to split it and all? So after this, our next element 1, 2, 3, 4, 5 done. Next element is 6. So 6 is greater than 4, right? So good. I'll come to the right side. Again, there is a space, so I'll just put 6 here. Okay, so no need to push it up anything. It's everything is correct. So our next element is what? 6 done. Next element is 7. Again, 7 is greater than 4. I'll come to the right side. So I'll put 7 here. Okay, again the same thing. I have to push it up there. Okay, so just see the median part. Okay, now what I have to do, I need to push 6 up. Okay, the moment I'll push 6 up, then 6 will come here. Okay, then again there will be a overflow condition for this internal node because here two keys are possible but two keys are already available. I have inserted 6. So what I have to do? I have to push it in again. Okay, I'll just draw the intermediate step at first. So suppose this is 2 and 4. 1 remains same. This remains same. 6 will come up there. Suppose 6 is just there. Then 5 should come to here and just imagine. Okay, then 6 7 will come here. Okay, now you see this is just intermediate step. Okay, just intermediate step. Now see, once I just uh, push 6 up, everything is violated. Okay, the moment I push up 6 there and splitted these nodes, now for this here there are 4 children, which is not possible because it's a three-way tree. So maximum children can be 3, and here it's 4. Again, the moment I added up 6 here, again is the problem. Maximum key possible is 2, now it's 3. So what I have to do? I need to split it up again. So for these nodes, I have to take the median, which is 4. So 4 will be push up there. Okay. So what will be the final for this one? I'll put 4 here. Okay. So after putting 4, I'll split these two. That means 2 will come here and 6 will be the right of your 4. Right. So after that means rest of the thing will remain same. For 2, there is 1 and 3. 1 and it's 3. Okay. Now for 6 we have 5 and 7. So from 6 it will be 5 and 7. So this is the way. So after this medium portion we got this tree. So 4 is the median for this case. It's push up. So 2 children, 2 is in the right side, 6 in the 2 is in left side and 6 in the right side. Okay. So our next element is what? It's 8, right? Now 8 is greater than 4. So I'll come to right side, correct? Now 6 is greater than 8. But the thing is, I have already a space there, so I can just put 8 here because it has a space. If you don't have space, then only you will go down, right? So I want to add 8, so it will just come to the right. There is a space. I'll just add 8 here. Okay, so our next element is what? Say it's still following the BST property. 7 is to the left of 8. Correct. So our next element is 9. Okay. 9 means it's greater than 4. Again, it's greater than 9. 8, sorry. So I have to add it here. But the thing is, I cannot add it here directly. Why? 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 You're getting my point? Are you getting the point? 9 is greater than 8. It should come here. There is a space, but I cannot add directly because why? I cannot add this 8 here because 8 is greater than 6. Actually, I have to put it here. Okay, 8. I added it wrongly here because 8 is greater than 6. I have to put it here. So now I need to add 9 here. Okay, I just missed one step directly. So I need to push 9 here. Now you will again do the same step. We have to push 8 up there. Okay, so after you want to push 8 there, what will be the tree? 4. It's a bit long process, so just be careful. Okay, so at this point overflow condition occurred after inserting 9. So I'll push 8 up there. So it will come here. So after that 7 will come here. 7 will become left of your node 8 and 9 will become right of your node here. So this is the tree right now. For this case, we have tree. Is this one clear to you guys, everyone? Okay. So our last element is 10. Okay. So 10 is greater than 4. So I'll come to right side. Again 10 is greater than 8. Okay. It's greater than first you compare with 6. Okay. 6 then 8. 8 greater than 10 and it will come to the right side. Now I have a space here so I can directly add 10 here. So this is your finally B tree. Okay. See all the leaves are at the same level. Okay. All the leaves are at same level. So what's the process? Just remember if it's a M-way tree, order is M, then children will be maximum children is M, max children, and max key will be M minus 1. Okay, so these are the two things you need to remember when you want to add or insert anything in a B tree. So suppose you want to search an item now. Okay. So suppose you want to search number 5. So what will be the process? You want to search for 5. So you will compare with the root first. So same process with the BST. So first compare with 4. 5 is greater than 4. So I'll come to the right side. Again in the right side I have number 6 and 8. So I'll compare with 6 first. So 5 is less than 6. So I'll come to the left side of 5. Okay. So and I'll get the 5. The same thing is applicable to other nodes like 9 or 10. Okay. 10 is greater than 4. I'll come to this node right side. Then again there are two keys 7, 6 and 8. So I'll come to the right of 8 and I'll get the value. So main point is if space is available, maximum key is not completed, then you can add any item, and if it is done, means overflowing, then you have to find the median value and push it up. And the whole process is bottom up approach. Is everyone clear? Insertion process, is it clear? Just see one more time. 2, 3, 4 to here. Okay, clear? Good. Anyone has any confusion? Okay, if yes, then I'll go to the delete process. Delete process is comparatively complicated for B3. Insertion is still simpler. You just need to push up the median value once you get the overflow condition. Okay. For deletion, we have to maintain like so there are lots of different cases for delete. Okay. Now we come to delete process. Okay. So in delete process, we have like one case, two case, and case three. Okay, we have three different cases. So your first case is if the key to be deleted lies in the leaf. So if, okay, in case of B tree, you can delete an item either from the leaf and even in the internal position, but the thing internal nodes, but it will always start from the leaf. Okay. So if key to be deleted in the leaf, there are again two cases, sub cases. The deletion of the key does not violate the property of minimum number of keys. So in case of deletion, we need to maintain two things. One is maximum key, one is minimum keys. Okay. In case of insertion, we were only concerned about maximum number of keys. But in case of deletion, we have to also take care of limit of minimum number of keys. Okay. So, the deletion of the key valid property the minimum number of keys node should hold. So, in this case, we have to borrow a key from its immediate neighboring sibling node in order to left to right. So, if it violates the minimum number of elements or keys, so we can borrow the nodes from either left sibling or the right sibling, but we always start from the immediate left sibling. Okay, so if the left sibling node has more than a minimum number of keys, then we can take it from there. But again, if your left sibling is full, means it cannot give you one key because it's already in the limit, then we will borrow from the immediate right sibling. Again, there will be different cases, like if both the siblings are not able to give your keys, then again there will be different case. So deletion process is comparatively complicated. That is just because there are too many cases. Okay, so suppose we need to, for deletion we need to take care of certain things. Insertion, everyone clear? Only two, only Deepa Niva said yes. Wes, okay, it will say yes. Now for deletion, we need to take care of three things. What are the three things? We need to find the maximum children, and we also need to find minimum number of children. Okay. So for example, your tree order is 3. Okay. So if your tree order is 3 or anything, okay, let's take a bigger number. It will be easier for you guys to understand. Suppose your tree order is just example. Okay. Suppose your tree order is 5. Okay. So if your tree order is 5, that means what? What will be the maximum children? I'm just showing um, the calculation part. So maximum number of children can be what? It's 5 because order of 5. That means there can be 5 children. What will be the minimum children? Minimum number of children will be 8m divided by 2. Ceiling of m divided by 2. Okay. Ceiling of m divided by 2, I actually mentioned it in the first class. So what will be the 5 divided by 2? What's the answer for 5 divided by 2? What's the answer for 2.5? So if it's 2.5, what will be the ceiling value of 2.5? Ceiling value of 2.5. Ceiling is the next highest integer. For 2.5, yes, correct. Ceiling value is 3 and floor value will be 2, right? For 2.5, your ceiling value is 3 and your floor value is 2. Always remember this concept, okay? So minimum number of children for a tree with order 5 is 3. Now what is the uh, maximum key? Maximum key is m minus 1. So 5 minus 1 is 4. And minimum key is, your minimum number of key will be m by 2 same ceiling minus 1. Okay, for maximum key it's just m minus 1 and for minimum it's just ceiling value of m by 2 minus 1. So answer will be what? 3 minus 1 is 2. So in a node with order 5, maximum children can be 5 and maximum key will be 4 and minimum children can be 3 and minimum key can be 2. So whenever we want to delete the item, that means what? It has to check whether the nodes have at least minimum number of 2 or not. If not, we have to try different things. Okay. So for 5 it will be a bit bigger. I'll just take order 3. Okay. Suppose this is the 3. I'm just drawing a order 5. Okay. Order 3. Order 3 means maximum children can be, for order 3, max children, maximum children is 3 and minimum children is what? M minus 1, 3 minus 1 is 2. What is the maximum key? Sorry, its minimum children is ceiling of m by 2. So 2 divided by 3 is 1.5 and ceiling value is 2 again anyways. So for maximum key will be m minus 1, so it will be 2 and minimum key is 1. Why? It's m by 2 minus 1. So 3 divided by 2 is 1.5. So it will be 2 again. So 2 minus 1 is 1. Okay. So let's take,
Good morning.
So this is your tree with other tree. Okay, just that orientation is a bit bad for me. Just understand it, okay? So suppose this is the tree and I'm going want to delete something from somewhere. So let's just start with the delete. I want to delete any node from the leaf. Okay, so for deleting node from the leaf, there can be two sub cases, right? So suppose I want to delete 32. Okay, first I want to delete 32. So first what you need to do, you need to find 32. Okay, so how to find 32? We have to go to the root node. So 32 is greater than 20 and less than 40. So I'll come to this subnode. So in this node again 32 is greater than 30. So I'll come from this node and it's here. Okay. So now I want to delete 32. If I want to delete 32, is it going to affect your key? Is it going to affect your key? Means minimum thing. Your minimum number of key is 1. That means what? Even if I delete 32 from here, it's not going to hamper the property of P2. Correct? So in this case, I can directly delete 32. Okay? And I no need to worry about anything. Okay? In this case, I can directly uh, delete 32, and after deleting 32, I'm just doing it here, okay? Not drawing it again. So I can just remove this data from here. Okay, I just deleted 32. Okay, just right. Maybe it will be easier for you guys. Okay, so I can just delete 32. It's here. Now this is one subcase. Now suppose there is only one node left here. Now I want to delete 31. Okay, I want to delete 31 now. Now again same process. How you will find 31? Follow the same thing. 31 is here. Now you see, if I want to delete the 31, it's violating the property. Correct? Why is violating the property? The minimum number of keys should be 1. If I delete this one, because 32 is not here right now. Correct? 32 is not here right now because I have deleted it previously. Okay, just delete it now. Okay. So 31 I want to delete here. So if I want to delete it directly, what I need to do? What's the condition? I can take item from either left sibling or right sibling. Okay, right sibling means what? Right sibling means this is a 32. So if I want to delete this one and it's violating this, so what I'll do? First I'll visit the immediate left sibling. Okay, and if your left sibling node has more than a minimum number of keys, so I'll just borrow the key from that node. Else I'll check the right sibling. Okay, so first I'll go to the left part. What is the left part? Left sibling is your, what is the left sibling? Parent of 31 is 30. So what are the other left side? Left sibling means these nodes. Okay. So immediate left will be your 28. Okay. That means what? I can just take, I'll just push this 28. 28 is your left. I'll push it up there and I'll move this 30 down here. Okay. So after this, I'm going to just modify in this tree because I don't want to draw the whole thing again. So just remember, if I want to delete 31, that means what? I cannot directly delete because it's violating the minimum number of key. So what I'll do first, I'll see the left sibling. If left sibling is this one, this node, if this sibling can borrow or give me one key, then I'll just take it from him. Now again, I can not just directly take the value from here and put it here. If you delete this 31 and put this 28 here, is it going to keep your BST rule? 30 is here and 28 is here. 28 is okay. So I'm just showing for this node. Okay, 30, 33. This is your 25 and 28, and this is your 30, 31. Okay, so you have to see the left sibling first, then only you will go to the right sibling. Okay, this meeting is going to end in 5 minutes, so I guess I'll just start in the next class because deletion process is long one. So anyway, I just want to quickly show this one because I have already started. So go to the left sibling. This has maximum 2 number of keys and minimum number is 1. So I can take the value from the left sibling, but I cannot directly interchange the value. I cannot just delete 31 and write 28 here. I cannot just directly write it here. Why? Why I cannot do this? See, the parent is 30 and 28 should be in the left of 30, correct? But I cannot just interchange. That means what I have to do is 31 is here, 28 is here. So I am going to take this value 28 to the parent and I'll keep down this 30 to down. Okay, that means what? I'll just so I'll just take this 28 value to the parent and push this 30 down and delete this 31. That means what? After deleting, this will be your 28 and this one will be 30 and this node will be empty. Okay. So after deleting 31, the main structure will be like this. Okay. 31 I cannot directly delete because violating the B-tree property. So I'll go to the left sibling and I'll just interchange the value with the parent just to maintain the BST property. So 28 will go up there, 30 will go down here, and it's still maintaining the property because one key is still there. Okay, this is one of the sub case of the case when we want to delete an item from the leaf node. Okay, so I'm just stopping here. Is this one clear to you? Just this sub case, is it clear to you guys? Just this case. So we are deleting at the leaf. Anyway, I'm just stop sharing. and take your attendance. It's going to end. Is this clear? That just one sub cases I have. Insert process clear to everyone, right? project. Okay. सबे बुझी पाइसा? सबको समझ में आया? Insert process I guess सबका clear है. Okay. Delete process just start किया है. Just one sub case I hope सबको समझ में आया. We want to insert in the leaf node. Okay, anyways, I'll just start again from tomorrow, only the delete process. Okay, delete process has 3 cases. Again, in these 3 cases, we have to do sub cases. So we'll start delete process tomorrow. Okay, okay, thank you. I'm ending the meeting now.